A quadratic function is any function. Now you're going to have to think back all the way to linear when we did lines. Function is a fancy word for what? Function. Equation.
Equation.
Is any function or equation.
Do we have to put the equation in there?
That can be written in the form y equals ax squared plus bx plus c. The difference is we've been dealing with just this part, ax squared plus bx plus c. When we dealt with polynomials, we just had this part. We're adding y equals, or we're adding the equation part. Before it had been an expression, because there had been no equal sign. Now there's an answer to our problem. We've done the basics. We've done the practicing of factoring. And the factoring was our answer. Now we actually have an answer. We're going to be doing some solving. So what you need to remember about this, the identification part, right? Identifying is super easy. We love to do that in math, right? Because it's yes or no. We're looking for the exponent must be 2. If the exponent is a 3,
It's not quadratic.
it's not quadratic, it's cubic. If there is no exponent,
Then it is linear.
it is linear. The exponent must be 2. That being said, your a value cannot equal 0. Because if your a value is 0, what happens to your x squared? What does it do? It disappears, right? It's gone. So if your a value is 0, you have no x squared, meaning it's not quadratic. And it must have y equals. Or if it's written in function form, do you remember what we put instead of y equals in function notation?
F of y.
F of x.
I would think F of y could be silly.
Or g of x, or h of, I mean, one of those. You know, it's like a Matryoshka doll of math.
Getting smaller and smaller, something surprise
It's turtles all the way down.
Turtles all the way down. You're right, Jacob.
I don't even know what that means.
It's from a physicist talking about space.
And one old lady said that,
And-
that the earth is just a shell of a,
Yeah,
of a
it's on the
turtle.
shell of a turtle, and he said, "Oh, ma'am, well, what's the turtle on?" And she looked at him and said, "It's turtles all the way down."
She's saying it's sitting on every turtle and it's sitting on every turtle.
Everything's on top of a turtle. All right, piece of paper. Someday this will unfreeze on us. Fold it in half, so put it horizontally, not tall like a skyscraper, horizontally. And fold it in half, top to bottom. So you've got a
Hot dog is this
long
hot dog or
rectangle.
hamburger style?
Hamburger style, I think. I don't know. Hot dog? Who knows? I have not.
You didn't spend enough time in it.
I did not have enough time in elementary education. All right, there we go. All right, so make sure you're writing on it the correct way. I mean, this is asking a lot the first day back from spring break, I know.
You're asking for too much.
I'm tired.
Identifying quadratic functions. We're not going to glue it yet. We'll glue at the end. Make writing a little bit easier.
Did you just wrong?
Too many folds. Identifying quadratic functions. Identification questions are yes or no. They're fantastic. Is it quadratic? Yes or no. The hard part is when it asks you to explain, you know, because it asks you to write words. I know, it's going to be a lot.
Why are you asking for so much in the first day of school?
Are we gonna write on our homework?
I mean, if it says explain,
Do I have to?
yes.
How many for-
You are going to explain it.
Is it points per word?
Yeah.
Is it word per point?
Y equals 3x plus 20. Y equals 3x plus 20. Is this quadratic?
No.
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 Because there's no a percentage.
What's your a value?
3x.
Negative.
Oh, negative
No, I'm saying negative as in wrong. It is not 3.
3x.
No.
3. The y.
0. Because the a value is whatever touches x squared. Isaac, focus. And there is no x squared, so our a value is 0. What's the b value?
3x.
3. And what's the c value?
20.
20.
Positive.
Positive 20. Good. Is this quadratic?
No.
No. A equals 0, which cannot happen. Says it right here. There is no exponent. I'm not asking for a novel.
Well, where you're going, you're gonna get a novel.
Oh, that's your choice then.
You don't just fool with it, right?
Good. Y equals, next one, y equals x squared minus 3. Y equals x squared minus 3. Is this quadratic? So let's see.
Yes.
What's the a value?
X squared.
1.
Wait, what?
1x squared. What's the b value? 0. Because there is no x value. There's an x squared, which is my a, but there is no x. And what's my c value? Negative 3. Let's see, does it meet my criteria? The exponent must be a 2.
Yes.
A cannot equal 0.
It does not.
Does not equal 0. And it must have y equals or f of x equals or some other form of that. So is this quadratic?
Yeah. I don't know.
Not apparently. Yes.
Yes. And we don't have to explain.
Because it worked.
I don't want to write it.
That's discrimination.
G of x equals 2x squared plus 4x minus 3. G of x equals 2x squared plus 4x minus 3.
You know, if it says f of x, I will immediately convert it to y. Because that's what I'm familiar with. Or at least I will try to.
All right, so let's talk it through. What's your a value?
2x.
2. What's the b value? 4. And what's your c value? Is this quadratic?
Yes.
How do I know? Well, the exponent must be 2. Check. A cannot equal 0. Check. And it must be y equals or f of x equals or some form of that, right? It must be an equation. It must have an equal sign. Okay, so let's try this. Y, plus 3x squared equals 10. Y plus 3x squared.
A red flag is showing up in my head.
Okay. Hold on. Let other people see if their red flag shows up. Jacob, why is there a red flag?
Because this is not y equals.
There is a y, but it's not y equals. You're right. But using our algebra skills, can you rewrite it so it is
Yes.
y equals?
Yes.
Can you get y alone?
Yes.
Sorry, my brain's a little rusty.
Nope, you're good though. I'm glad that you noticed it. Because most people, either your brain goes on autopilot and you automatically say, no, it's not, because it's not y equals.
Or it gives you the sound tree.
Or it says, no, it's not y equals, and hopefully your brain says, oh, but wait a second. I can make it y equals. When I do this, what do I get as my answer? Y equals what? What do I get? Negative 3x squared. The minus belongs to the negative 3x squared. Plus 10. What's my a value? Negative 3. What's my b value? 0. And what's my c value? Is this quadratic? Yes. All right, one more.
Why we can't have nice things.
Never.
Y plus 3x squared equals 10 plus 3x squared. Y plus 3x squared equals 10 plus 3x squared.
A red flag is showing up in my head again.
Okay, red flag again because
This is not y equals.
it is not y equals. But can we make it y equals? Yes. So y equals what? Ten.
This is not a quadratic function because there is no a value. It's 0.
No, this is not quadratic. 2 reasons why. Because a equals 0.
And does that automatically mean no exponent?
And automatically that means there is no...
So why do we have to put no exponent when we already know that?
Just to drive it home. You know me, Jacob, over-explaining, right? All right, glue right underneath.
Your brain would just
rot away.
But I thought my brain was gonna rot away? What'd you ask? No, I'm not worried about my brain rotting.
Right, so identifying quadratic functions. Identifying quadratic functions. Not too terrible. Yes or no?
Yeah.
I mean, I'm saying all it's asking you is yes or no, right?
Yeah. More pieces of paper.
All right, so if it's in an equation form, it's pretty easy to identify. I mean, not too shabby, right? So what if they give you a table?
Isn't that exactly?
When given a set of ordered pairs, right, a relation. Luis is right. Luis said, isn't that a graph? Sure, you could graph it. We haven't gotten to that point yet. But sometimes drawing a graph and plotting the points is more work than we want to. I mean, if they don't tell us specifically to graph, we tend to not graph it. Just because it's more work than we're willing to put forth at that time. For example, here's a set of ordered pairs. -4, 8. -2, 2. 0, 0. 2, 2. And 4, 8. And remember, we know that they belong together. They go together because they've got those squiggly-doo brackets on the ends, right? Which tells us they have some type of relationship. I just want to know, is that relationship that they have quadratic? Flip back in your notebooks to page... Let's find it. Linear functions. Turn back to page 17. I know, right? So long ago. When it was a linear function, we looked at the change in y over the change in x. So we looked from 4 to 8, from 8 to 12, from 12 to 20. The change in y over the change in x. What's that called? Do you remember? Slope. We looked for the slope. So if it was linear, we did the change in y over the change in x. But we're quadratic now. And quadratic means exponent of what? 2. So it's not the change in y over the change in x. It's the secondary change in y over the change in x. Because the exponent is 2. It's the secondary change in y. So not the first change. I'm looking at the change in y. I'm going to see from what to what? From what to what? I'm looking for a pattern in my y's. I'm finding the first changes, but I'm not looking for the first change. I'm looking for the secondary change. I'm looking for the second change because it's exponential. It's an exponent of 2. The secondary change in y over the change in x. So I like to write it in a table form just because I think that's easier sometimes for our brains to see. So -4, 8. -2, 2. 0, 0. 2, 2. And 4, 8. So I just took this same relation, group of ordered pairs, and put it in a table because it's sometimes easier for me to look at. And I'm finding not the change in y, but the secondary change in y. So I have to find the first change. From 8 to 2 is what? What kind of 6? 8 plus 6 is 2? -6. From 2 to 0.
2.
-2. From 0 to 2. +2. And from 2 to 8. +6. These are clearly different, right? But I'm not looking for the first change. I'm looking for the second change. So let's look now. From -6 to -2. +4. From -2 to +2. +4. And from 2 to 6. Is the secondary change constant? Yes.
The primary change is not. Actually, it is.
So it's not linear. If it was linear, the first set of changes would be constant. It's not linear. It's quadratic because the secondary change is constant. Let's check our x's just to make sure, right? From -4 to -2. +2. From -2 to 0. +2. From 0 to 2. +2. And from 2 to 4. So those are good. The change in x. Change in x is the first change in x. So is this quadratic? Yes. Why? Because the secondary change in y over the change in x is constant. Now, what if you did all of this work, right? You found your changes in y's, you found your changes in x, and you had something that looked like this. Your change in y was 4, 4, 16. And your change in x was 2, 2, and 8. Would you say no? I'll tell you now, the answer is yes. That is quadratic. Why is a change of 4 over 2, 4 over 2, and 6 over 8 quadratic? Cannon, why? Yeah, because 4 over 2 is equal to 6 over 8, correct? Because they're proportional. Check your proportionality. Don't go on autopilot.